Hello, I am Yaroslav from Lightnovo customer support, and today I will demonstrate you how to use Lightnovo Python SDK for Linux. So I have two files, timescan.py and timescanviewer.py. Timescan would acquire the data sequentially from this mini Raman spectrometer currently connected with the USB cable to the computer, and timescan viewer would help you to explore your data. So in the beginning I'll go through live demonstration, and then I'll explain the code. So we start the terminal in the folder, and so to mention in the beginning that I'm using the flavor of Ubuntu Slimbook OS supplied for Slimbook laptops, but our software works really well on other Linux operating systems such as conventional Ubuntu systems, Raspberry Pi OS, and so on and so on. I can actually confirm that this is Ubuntu. Just type in this command, and the Python version I'm using, so it shows Slimbook OS, but Ubuntu release 24. Python version, it should be like that, Python 3.12.3, but it works well on newer releases as well. So I start the timescan logger, the timescan.py, and at the moment the device has middle distance probe and the polystyrene Lightnovo standard polystyrene sample attached to it. So we start the timescan.py, and you can see it launched the GUI immediately, and it typed some information. So in the beginning it was connecting to the port, searching through the ports for mini Raman, and it took it only 4 milliseconds to connect. This is the port name. Shows some information about device model, firmware, laser count, because some of the devices can have 2 lasers, and so on. Spectrometer channels as well. So we go to the GUI, and we can turn the laser on. I'll show it to you now. It's actually blue. I turn the laser on and it turns red. Then the laser off, it's blue. Laser on, red. Let's keep the laser on and start the time scan. And as you can see, we have a nice spectrum of polystyrene, but actually I see that the intensity is a bit low, so I can adjust the focusing. I adjust the focusing and the signal should go up. You see it's 250, 350, 400, 400, 600, 700, 800, 1000, 300. We're probably somewhere in the maximum over here. And let's wait for a while, and then we can actually stop the time scan, and later we can record another time scan. I mean, right now we can, for example, what we can do, we can disconnect the polystyrene sample and we can start another time scan. For example, now sunlight, this is the sunlight, I turn it the other way, less sunlight, then block with my hand, almost 0. Let's stop this time scan, and actually what I also have, I have a couple of pharmaceutical samples, and we can we can start the time scan with polystyrene. With paracetamol, and I adjust the focusing. So basically, by putting the sample in the focus, you can optimize the signal. Now the spectrum is quite intense, I must say, for 300 millisecond exposure. So everything works smoothly. Let's check ibuprofen. Here's the spectrum, and the spectrum looked like titanium dioxide. Let's stop the time scan, switch the laser off, and exit this program. Well, let's see what was logged in the folder. So in the folder we still see .py files and CSV files, which are the time scans. So let's launch the time scan viewer, Python timescan underscore viewer.py, and we can explore the time scans. So first time scan, as you remember, it was polystyrene, and we started from low intensity and ended with high intensity, and everything is color coded with respect to elapsed time. Another time scan, the second time scan, we just measured sunlight. Over here you see sunlight, then I blocked it with my hand. In the very end, this yellow curve, everything looks nice. Then the third time scan, pharmaceutical samples, and we see this dark green is the spectrum of paracetamol, and then over here we had nice spectrum of titanium dioxide and the coating of ibuprofen. We can exit this software as well. And now I will go through the code. Let's check again. So timescan.py, and then we use VI editor to explore the code. Let's go to the very beginning. So as you can see, let me expand the window. The GUI is based on TK of these examples, TK inter. We import LNMR, which is Lightnovo SDK. Then we use standard Python modules, which are supplied with Python time and threading. Very famous module for Python, NumPy for numerical processing, and matplotlib for plotting. So here the code starts. We connect to the device, then we time this. So over here, connection to the device, we have LNMR call to SDK. When it's empty string, it will be looking, scanning for all the ports, which, as you can see, it's done really fast. Then we time this using TikTok construction time module. We print it out. Then it gives some metadata like the device model, reading from the device and print on it. So over here, this section, as well as getting the Raman shift range from the device. Then we set the device. As you can see over here, we use laser power 50, meaning 50 milliwatts. We set the laser off in the beginning for safety reasons over here, and we track the laser state with a Boolean variable. The exposure time, we set it to 300 milliseconds. Repetition count 1, because it can also be integrated on the device multiple times, and the gain to 1 as well. Then here goes the standard section of TK inter GUI, and the matplotlib canvas. You see captured spectrum caption, then Raman shift axis, intensity axis, and plotting. Then over here we have scan control variables helping us, and core functions, which are called in the main loop. And it's single capture over here to capture the spectrum with LNMR calls, append the scan to log file, update the plot, the scan loop itself, toggle scan, because as you saw, we were able, with the same software launch, we were able to do multiple scans, and the scans are saved in the timescan file with a timestamp, as you can see here, timestamp. Toggle laser, laser on, laser off. Exit the app function with root destroy. We also have some description of the buttons. Here, as you saw, it was laser button, capture button, exit button, and over here, this line is to run the software window of GUI on the second screen, which actually I'm using now when I'm recording this video. So we quit this, and let's check the timescan viewer. And timescan viewer, it's actually just a helper to read this format, which was logged by another program and plotted graphically. So again, tkinter GUI, NumPy, pandas, another module to read the data quickly to data frames, matplotlib for plotting. And if we scroll through the file, we scroll, as you can see, it's not that big, and mostly matplotlib calls and tk. Tk, here's the main loop, and it's 171 lines of code. So I hope you enjoyed this demo, and if you would like to acquire SDK, so we have SDK for Lightnovo instruments available for both Windows and Linux, on actually both Python and C, so 4 combinations in total. And if you would like to acquire this SDK, please contact us. Subscribe to our channel, and see you soon with next tutorials. Thank you. Bye.